Okay, the problem I'm going to show you right now is how to evaluate the limit of a function that has a square root in it, and that's going to involve using the conjugate. Please try to ignore this squeaking. That's Carlos playing with a toy, and it's impossible to get him to stop. So we're going to have to deal with that. All right, so if we direct substitute a 0 here, you notice we get 3 minus, and then the square root of 9, which is 3. So 0 on top, 0 on the bottom. That means that we have a hole in the graph at x equals 0, and we need to do something to remove that discontinuity. So that something that we use is multiplying by the conjugate. So we're going to change the sign of the middle right here. So keep 3, and then the negative turns to a positive. And then just copy the expression that's underneath the radical. And we're going to do that to both, sorry, I know that's annoying. We're going to do that to both the numerator and the denominator. And in essence, what we're actually doing is just simply multiplying by 1, because something over itself is 1. Now, I'm going to caution you, in the denominator, do not actually distribute this x. Just copy it. So here's what I mean. Let's do the denominator first. So in the denominator, we're going to show that there's multiplication, but we're not actually going to multiply the terms. So normally what you would do is you distribute this x and get 3x plus x root 2x plus 9, but leave it here and I'll show you why, because you're going to be able to see that it cancels out. All right, now in the numerator, don't forget, you have to FOIL, okay? Because we have 2 terms times 2 terms. So 3 times 3 is going to give you 9. And then the reason I'm going to skip the outer and the inner of the FOIL, so normally we do first, outer, inner, last. We're going to skip the outer and the inner of the FOIL because when you multiply something times its conjugate, the outer and the inner are going to add to 0. And if you look at this, you would get 3 root 2x plus 9 minus 3 root 2x plus 9, which adds to 0. So all you have to do when you multiply something times its conjugate is multiply the first times the first and the last times the last. Now be careful right here. This is going to be minus, so you have to put parentheses around the product here. So not minus 2x plus 9, minus the quantity 2x plus 9. And if you don't do that, you're going to get messed up on the rest of the problem. So now we have the limit as x goes to 0, and you're going to distribute this negative. So you would get 9 minus 2x minus 9. So the numerator is just minus 2x. And again, don't distribute in the denominator, because if you would have, you wouldn't see that now, remember the discontinuity that we want to remove is just x equals, or x plus 0 or x minus 0. We just want to remove an x. Well, here it is right here, an x and an x. So we can go ahead and remove those, and now we can actually direct substitute a 0 without getting indeterminate. So now that that's done, we're going to do the limit as x approaches 0 of negative 2 over 3 plus the square root of 2x plus 9. And we're going to go ahead and direct substitute in the 0. So we're going to get negative 2 on top, and on the bottom we get 3 plus root 9, which is 3. So we get 3 plus 3, which is 6, and that simplifies to negative 1/3. Okay, so I'm going to do another one, and in this one, I wanted to show you what happens if you have just 2 radicals in the numerator. This is definitely something that you have to know how to do. I'm not going to give you one on the test that has a radical in the numerator and the denominator, but if you have 2 in the numerator, it's not as bad as you think it is. So if we direct substitute, we would get 3 plus 2, which is 5. Root 5 minus root 5 is 0, and then 1 minus 1 is 0. So we know we have to multiply the conjugate, and what we have to remove, since 1 caused the discontinuity, we have to remove x minus 1. So we're just going to multiply the numerator and the denominator by the conjugate. And I'm going to put parentheses around this. Don't forget, in this bottom right here, don't actually distribute the x minus 1. So we get the limit as x approaches 1, and now we do first times first, so that's 3x plus 2, and then last times last. Root 5 times root 5 is 5, so this is minus 5. And then, look, I didn't put any parentheses around it because it was just a 5. In the last one, it was multiple terms after the minus sign, so I needed the parentheses. But if it's just one term, you don't actually need it. And now in the denominator, we have x minus 1 and then the conjugate. So just copy that. Okay, and now let's simplify and see what happens here. So we get the limit as x goes to 1. So on top we have 3x minus 3. And then in the denominator we have x minus 1 times that conjugate. Now, we already know that the discontinuity is happening at 1, so we need to just factor out an x minus 1. Well, we don't actually have that on the top, but it is there, obviously, because we can take out the GCF in 3x minus 3 and just rewrite that as the limit as x goes to 1 of 3 times x minus 1 over x minus 1 times the square root of 3x plus 2 plus root 5. Sorry, I'm running out of room. And now we can cancel the x minus 1s. Okay, I'm going to just erase some stuff up here so I have room to write. So I'm just going to go back up there with the rest of this problem. So here's what we have. The limit as x approaches 1, the numerator is just 3. The denominator is just the conjugate. So 3x plus 2 radical and then root 5. And then we can go ahead and direct substitute the 1. So we get 3 over root 5 plus root 5. And that's equal to 3 over square root of 5 plus the square root of 5 is 2 root 5. And you're not allowed to leave radicals in the denominators, so you have to rationalize. Hopefully you remember that from pre-calc. So we just multiply top and bottom by root 5. So we get 3 root 5 over root 5 times root 5 is 5 times 2 is 10. So our final answer, completely rationalized, is 3 root 5 over 10.